Okay, so the algorithm has just gone through and it's just finished scrubbing the shape. So now we're ready to plot the lines and see if we manage to see any more of those duplicate lines that we missed out the first time round. Okay, so to do that we have to issue the shape extract command. Do that. Right, there we go. So there are all the lines that that come through after passing the duplicates option into the fingerprint. And what I'll do is I'll start by hiding them. Hide, and then start at the top and just see what we've got. Yes, we've seen that. That's the outer bounding region, L0. We know that exists. Yeah, we've seen that before. Yep, that's a new sort of independent loop line. Yes, that's a bound. So is that. Yes, another bound. Another one. Yep. Right. Okay, so we've found some of these sort of self-closing loops that we missed the first time around. So that's good. So let's continue on and see if we can find if the entire shape is defined. If all the shapes are defined. Yes, that's a bounded region. Yes, so is that. So is that. Okay, that one is a bounded region, but like we outlined earlier, that's an exo shape. So we want to ignore that for now. Another exo shape. Okay, that's okay. That's an exo shape, but we'll keep it because we're interested in these outlying white areas, because there will be a process for us to use the smaller regions plus this exo shape in order to get this this outer white region. That's an exo shape. We want to ignore that. Another exo shape. That's okay. That's a fundamental area. Exo shape. Exo. That's another fundamental area. Okay, close to fundamental area, but actually it's got this extra blue little line there, so we want to ignore that. Yep, that's a shape. That's a shape, but again, this has a dark blue region that we want to miss out. So let's try something else. Yep, there we go. Let's found it. That's an exo shape. And that's another exo shape. Okay, so we've got pretty good coverage of all the lines in the shape, all the fundamental lines in the shape. But still to do is to find these outer wider regions. Okay, so that's good. Maybe now what we can do is we can try the same approach, but looking at a different shape. So what we'll do is clear the command line, CLC. Let's see. Okay, this is St. James. Let's try Westmoreland. Okay. Right. Okay, first things first, we've got to load in the data for Westmoreland. So load. Actually. Westmoreland into the edge. Okay, great. First things first, we've got to go into this shapegen function and just modify and get it to give us the non-duplicates first. We'll run that through. Bounds, shapegen. Okay, that's looked fine. Next step is to actually go through and actually extract the shapes. So we're gonna, yeah. Right. Okay, the algorithm is just finished extracting the shapes. So what we're going to do is we're going to scrub it, scrub the shapex variable, get rid of duplicates, and the next thing is we've got to now try and extract some shapes out of it. So let's go. Right, there's some shapes there. Okay. So just as in the previous parish, St. Elizabeth, because we run the non-duplicates first, we can see that we're missing this this single loop is missing because we've run non-duplicates first. Okay, so let's have a look. This looks interesting. Okay, let's just reset, just checking that it looks okay. Reset the view. So we're gonna just hide all the lines. and go through them step by step. Okay, yes, that's the outer line exo shape. We know that exists. Okay, that's a nice fundamental shape. Okay, that's an exo shape because it includes these inner bounded regions. Yes, nice fundamental shape. That's a shape. That's a shape. So is that. Shape. Nice shape. Yep. It's a shape. Good shape. Another shape. Yep. Okay, that's a bounded. That's an exo shape, so we want to ignore that. Okay, it's another shape. Exo shape. Exo shape because this green line is included inside it. That's a nice fundamental shape. Yep, it's a shape. Okay, this one is an exo shape because it includes this kind of purple, brown, and turquoise color. Exo shape. Another exo shape. Exo. Exo. Yep, fundamental shape there. Exo. Exo. Another exo. Okay, that's a fundamental shape. There's no there are no lines crossing. It's white space, so that's okay. Okay, that's an exo shape. Another one. That's an exo shape. Okay. Yep, and that's just the outer exo shape. Okay, so we've gone through and we found most lines except this this self-closing loop. And again, we've just got some of these spaces, these wider spaces, that are sort of the difference between a larger exo shape and the smaller ones. Those we will find at a later time. Okay, so that looks good. So we're just going to rerun the code, but this time just to find this this inner self-closing loop. So we go back into our shapegen file, we modify it. Actually, to duplicates, we issue it again. Gone through and it's found it. And then what do we want to do? We want to actually go through and actually extract the shapes for that. Okay, the algorithm has just gone through and it's finished running. Yep, we can go through and we can start to scrub it. Okay, so if we go into our figure, yes, this is what we saw initially for parsing the non-duplicates. Now you want to see for duplicate data, what do we have? Okay, so drag that across. Yep, ready to plot. Go. Right, it's gone through and it's found it. And if you remember that that particular boundary region that we were missing initially, it's now selected. So what we're going to do is just hide the new lines. Yes, we've seen that before. Yes. Okay, it's exo shape. Yep. Shape. Shape. Very good. So it's gone through and it's actually found the that sort of self-closing loop, almost like a circle. Yes. Smaller shapes. That's an exo shape. Okay, that is another shape. That's fine. Let's go. Exo shape. Exo shape. Oh, that's fundamental. Oh. Yeah, that's another fundamental shape there. That one is an exo shape. Exo. Fundamental. Exo. Okay, that is a fundamental shape. That one is an exo shape. Exo. Okay. Right, so it's gone through and it's we've been able to find most of the bounded regions. So that's very good so far. Maybe just one more time we're going to go through and try a different shape altogether. Okay, so now what we're going to do is we're going to go and we're going to try St. James. Right, where's St. James? Okay, that's St. James. CLC. What we'll do now is we're gonna shift